Hello, welcome to another coding challenge. This is another coding challenge that I'm going to do about President Barack Obama, who is still, during the time of this recording of this video, the active current president of the United States. Okay, so what am I going to do in this one? So part of the data set that was released was every single photo. So first of all, that I mentioned in a previous coding challenge, the White House recently released all of their social media data from the last 8 years and invited artists and researchers and people to remix it and make projects using that data. So one of the things I'm going to do here is just look at working with the image data. The Facebook download, which is 4.5 gigabytes, has tons of videos, but it also has a giant folder of images. So I have that here in this particular sketch folder. In the data folder, I have a single image, which is just the White House official portrait of Obama, and then I have every single Facebook photo. So I can scroll through these and see all of them. So what I'm going to do right now is I'm going to attempt to make a photo mosaic of this Obama portrait and with all of these images from Facebook. So I'm going to do it in the most drop-dead simple way possible. When I post the code, by the way, I'm not going to post the photo data set, but I will include like a README file or something to a link to that photo data set, because I don't want to post some 300 meg file to GitHub that you have to download. Okay, so let's go into processing, and let's just do a couple things first. So I'm using, for this coding challenge, I can minimize the browser and all this other stuff. I'm using a programming environment called processing. Go to processing.org. It's Java-based, and it has a lot of libraries for drawing and images and all sorts of stuff like that. So I'm going to make a variable called Obama, and I'm going to say load image. Was it obama.jpg? And then I'm just going to say image Obama 00. So let's just see. There we go. I need to actually make a size of the canvas, which is like, so let's see, what is the size of that image? It is, if I look at it, 600 by 749. So let's make the canvas 600, 749, and do this. We can see, there we go. So this is just, first of all, I have a processing sketch that loads this image file and displays it. So the first thing that I need to do to make this photo mosaic is figure out a way that I'm going to pixelate this image. And there's lots of ways I could do that. I'm going to do it in a pretty simple way. I'm going to sample it down. So I'm going to make the image smaller by a factor of something. So I'm going to say, let's have a variable called scale factor. And that's such a long variable name. It makes me so sad. I'll come up with something better later. Let's make that scale factor 8, for lack of a better idea right now. And then what I want to do is I need a new width, which is Obama.width divided by scale factor. And I need a new height, which is Obama.width divided by height divided by scale factor. And then what I'm going to do is I'm going to use the copy function. I'm going to make a variable called smaller, and I'm going to say smaller equals create image with. Sorry, I'm like really thinking hard here. Create an image with that width and height. That's an RGB image, and then I want to copy from Obama the entire image to this image's width and height. So I'm using the processing copy function. So I'm using processing to scale the image down. I could skip pixels or I could manually scale it, but this is going to be simple. And now I'm just going to say image smaller 0, 0. So let's see if that worked. And you can see that worked. Now I have that smaller image here. I just copied the image to make it smaller. Because the reason why I'm doing that is now what I want to do is I actually want to read the pixels. So I'm going to say smaller.load pixels. I guess making this photo mosaic is something I only need to do once, so I'm going to add no loop at the end of draw. There's no need to loop over and over again. And what I'm going to do now is I'm going to say for every x, and you know what, I kind of want these that w and h just to be a global variable, because that way I can use it over and over again without having to say dot, x less than width, x plus plus, y equals 0, y is less than h, y plus plus. And now, and you know what, this scale factor, let's just call this like factor. I don't know, scale, SCL for scale. And then now what I'm going to do is I'm going to say, what is the pixel? The color is smaller dot pixels, and I need that pixel, I need the spot of, so the pixels is a one-dimensional array, but I'm thinking of the x and y of all the pixels. So what I need to do is look for that index, which is x plus y times w. I'll link to some other videos about image processing that I have that go over this particular algorithm more specifically. But now I'm looking, this is an algorithm for looking at every single pixel in the image. Every x, y location, look at the particular color. And I'm going to say fill C, and I'm going to just draw a rectangle at x, y, and where do I draw those rectangles? X times scale, y times scale, and then that scale. So that scale is really the size of each one of these little squares. So now you can see I have this pixelated version of Obama where I've drawn a rectangle. And there's all these black lines, I guess, because I probably have a stroke. So if I had no stroke, we can see now I just have this pixelated version of Obama. So now what I need to do is instead of drawing a rectangle, I need to draw an image inside each one of those. And let's make the scale factor bigger. I'm using kind of round numbers. And you can see things aren't divisible by the right whatever, but that's fine, close enough. Let's say add background 0. So close enough, right? So we can see this is still giving us something here. We've got a pixelated version of Obama's portrait. Now what I need to do is really the hard part. So that was the easy part. The hard part now is I need to somehow load however many images there are. So let's see how many images there actually are. If I go here and I do Command I, we can see here that there are 3,934 images. So I think I can load all those images into memory, no problem. Let's see. The good news is they're mostly like small images. So one thing I'm going to do is I'm going to create an array of all images. And the other thing I need to do is I need to now dynamically be able to look into that directory and say, give me all of the file names in that directory. And there happens to be an example on the processing website. I know that it's there. Actually, it's because I made it, and I just don't remember how to do it. This is what I want. I want this function, which I give it a directory, and then it just makes an array of all of the file names and returns them back. So I'm just going to grab this code. Rather than write this from scratch in this coding challenge, I'm going to grab this code. And I'm going to stick it at the bottom here. And what I'm going to say now is, I guess it's giving me file objects, not strings, but that's fine. List files. Right? And then I want to give it a directory, which is data photos. Will this work? Print array files. So let's see what I get here. OK, so let's see if we get this list of photos. No. OK, what if I do sketch? Maybe it needs a full path. So if I wrap it in sketch path, which is a function that figures out the full path of the directory. There we go. So we can see here it printed every single. All right, now there's some extra stuff in there. So for example, why did I get some weird? So first of all, let's comment this out. Let's go to the directory. It looks like there is something extra in this directory. Oh, there's a folder called static. Oops, let's get rid of that. That was extra by accident. So, OK, sorry, that was a little mistake that has nothing to do with this video. So now I have all of those files. Now, print line files index 0. Let's just look at that. So it gave me that. So we can see actually toString will actually just give me that file path. Now notice, by the way, that first file is .dsstore, which is like basically the most annoying file ever. It always messes stuff up. But Mac operating systems put these like files everywhere. .dsstore, .dsstore, .dsstore. Rah! Okay, but we're going to ignore that file. I think everything else, luckily it's in the 0 spot. So as a quick hack, I could just ignore it. What I'm going to do is I'm going to say, first what I want to do is I'm going to say all images equals a new array with files.length -1, because I want to ignore that dstore file. And then I'm going to say I equals 0, I is less than all images.length, I plus plus. What I want to do is say string file name equals files index I plus 1, right? I just want to skip that first .dstore file. I really should write some code to check to make sure it's a valid JPEG, but I think we're going to get away with this here. And then I'm going to say all images index I equals load image file name. So I'm going to have an array with a lot of images in it. Now this should probably take a while to run. So let's see what happens. Could not find, so there's also a file called index.htm in there by accident. So rather than write code, what's this image? Let's ignore this one. Some nice images here. Let's hope that that fixes it. Loading, 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 come, come, come. You know what I'm going to do right now is I'm going to use a smaller subset of images. Let's just use 10 images right now, just to make sure this is actually working. 10 images. OK, so that worked. Let's use 100. 100 takes a little bit longer, but we can see, OK, so I'm loading a lot of images. OK, here we go. So now we have a lot of images loaded. So what do I need to do with those images? What I want to do, boy, this is tough. OK, so what I want to do is for each one of these pixels that has this given brightness, I want to find the image of the so I'm not going to do this by color. I'm going to do this by brightness. So let's adjust the way this looks for a second. So we can see if it's still going to kind of have the right look. It's loading 100 images. OK, so this is now the portrait. What I want to do is there are, technically speaking, there are only 256 brightness values. So what I want to do is in all those images, I want to find the particular image that matches a particular brightness value most closely. So the other thing I need to do is, and this is going to be very not sophisticated. I'm going to say brightness. What I need to do now, OK. Yeah, so what I'm going to do, brightness equals a new p image array with 256 images in it. Now the other thing I need to do is when I load each one of these images, I think what I'll do is make a corresponding array. Let's call this bright images and call this brightness. Let's just call this brightness. I want an array of brightness values. And truth be told, there's, but I got to figure this out as we go. So I have an array of all the images, and then I want to have an array of the brightness value for each one of those images. So after each one, I'm going to load pixels, and then I'm just going to look through all the pixels. This is going to make it take way longer, by the way. Pixels.length. So I need to look at every pixel, and I need average equals 0, and the brightness is this particular pixel's brightness. Woo. Right? So what am I doing now? For every image that I load, and I should sample them down. I really should sample them down because it'll make it run much faster, but let's just sort of see how this goes. Every single image that I load, I'm going to look at its pixels, I'm going to examine the pixels, and I'm going to add up all the brightness values, and then averages the sum of everything divided by the number of things, the length of the pixels. So now I have the average, and I can say brightness index I equals brightness index I, brightness index I, brightness index I equals average. Okay? So what I've done now is I'm just going to do 10. I'm going to run this, and I'm going to say print array brightness. Get rid of this. So let's look at this. Null pointer exception. So brightness is a new array with the same number of spots. And I should make like image objects. There's a lot of ways I could refactor this to make it make more sense, but this is pretty good. OK, so we can see now those 10 images each have an average brightness as listed down here. So like the first one has an average brightness of 158, second one has an average brightness of 83. So actually, in a way, we're kind of done. What I'm going to do, I'm going to do this in a remarkably inefficient way. Yes, no. So hard, so hard. Do I have nested int I, somebody told me? No, I think it's OK. I used j here where I needed to. So I think it's very tricky and confusing, but I used I and j in the right way. OK, so now what I'm going to do is let's do what I was thinking originally. I have kind of a better idea for later, but this is fine. What I'm going to do is now I'm going to say I need bright images. So I need to fill this bright images array. So what I need to do, and I said var here, it has to be int. OK, so I need to fill this bright images array. So what I need to do is find the image that's the closest in distance to a particular brightness value. So I'm going to say right now, closest, the record for being closest is 256, right? Because nothing, maximum being 255 minus 0, that's 255. So I'm going to now say I'm going to just use floats here. The difference is the absolute value of I minus brightness I. Right? In this case, the index is actually bright. I want to find for brightness 0, for brightness 1, for brightness 2. And not brightness I. I need to look at every single image. So I need to say, now I need to look at all of the images. And the difference is the current brightness, the absolute value, meaning the positive value of the current brightness that I'm searching for minus the brightness for a particular image. And if difference is less than that record, then record equals that difference, and bright images index I is then the all images index j. So take the corresponding image, so what I'm doing is saying there's 256 images I need. So should be j less than brightness.length. Yes, thank you, chat room. OK, so what I'm doing is I'm saying, here's all the brightness. I need to have an image for each brightness value. So I'm going to find the one in my all images that's closest to that value. And I'm going to duplicate some, and there's going to be lots of problems with this. But this should work. And to do that, I look for each brightness value. I look through all the brightness values of the other images, find the one with the smallest difference between the target, and then save that. So now, let's just run this and see that I don't get any errors. If I found, OK, so where am I missing? I've got like a bracket out of place. Another bracket here. OK. So oops, null pointer exception, because I forgot to create bright images is a new p image array with 256 spots in it. There we go. So I don't have an error yet. So now this is the moment of truth. What I need to do is, instead of drawing those rectangles filled with that brightness value, right? This is where I'm drawing the rectangle filled with that brightness value. What I want to do is say int index equals that brightness value. And then I'm not drawing a rectangle. I'm drawing an image. All images, no, bright images, right? This is the array that has all those images indexed by brightness. So draw the one corresponding to that brightness at x dash scale, y dash times scale, scale, scale. So I'm going to dynamically resize the image. And oh, because I used index twice. Image index. OK, here we go. Look at this. Hey, not too shabby, right? So we can see here, and you can kind of look in and see the level of detail. I only had 10 images to pick from, so it's getting a very, it's not that detailed, but let's try again with, let's try 50 images. I don't know how long this is going to take, but we can see we've got a little bit better now. And let's try 100 images. Waiting. Getting better. 200 images. I'm just going to be doing this forever. OK, great. So now what I'm going to do, actually, is I'm going to let it do it with all of the images. But there's going to be an edit point in this video. Not for those of you who are watching this live. There's no edit point. So I'm just curious if it works. OK, so I'm back, and you don't see the image yet. So a problem arose. The problem arose, which is that I got an out-of-memory error. So the out-of-memory error, that's a problem. And it's telling me that what I could do is increase the memory setting in preferences, which I did do. And I still got an out-of-memory error. So loading 3,000 images into memory, is kind of an issue. But I have an idea here. If I go back, so rather than have to increase the memory, this will also make it run faster. If I go back to doing this with just 10 images, you'll notice something. What I'm actually displaying here is like a really, really tiny image. So when I load the images, this is going to make everything run so much faster. I might as well then copy that image, resize the image in processing, and sample it down. So that when I'm analyzing the pixels, I have a much smaller amount, because I only need to draw a much smaller thing anyway. So I'm going to use that same technique, where I'm actually going to do this. pimage file, pimage img equals, I'm going to load that image. Then I'm going to say all images equals create image. And the image that I want to create, I'm just going to make it like a little rectangle. So I'm going to make it, I already have that size, right? Scale. So I'm going to make an image that's a tiny one, that's just 16 by 16, an RGB image. And then I'm going to say all images, index I, same exact thing I did with the Obama portrait to pixelate it. I'm going to say copy image, and I'm going to use the full size of that image. Although actually, you know what I should do? I should really make it a square. I'm not going to add this to the code because it would be complicated to figure out, what's its aspect ratio. But that would be something good to do, to just crop it. But I'll leave that for those of you who are so inclined to add that as an improvement to this. So this should be exactly the same thing, but run much faster. So you can see how boom it analyzes. So now let's do this with 100 pixels, 100 images, to make sure it's still working. There we go. Now, here we go. I am going to now edit this out again. I'm going to go back, and I'm going to put in all of the files. And here we go. OK, look, I did it. Actually, I didn't. I had to limit it to 1,500 images because I'm still having memory issues. I'm sure I could look at this more and figure out some ways to, load images as one way to do this actually would be to load and unload the images, but then only load them again when you need them. To rewrite all those, I could actually, what I probably should do is, I know what I should do. I should pre-process that whole folder of images and sample them all down. So I'm actually just loading the smaller images. That I could actually do rather easily. But I'm not going to do any of that now because it's time for this video to end. You sort of see the basics of this. I want to give you some things to think about to improve on this. I'll release the code. I would love people to, I'll put this on GitHub and see what improvements you make. Number one is there a way you can cleverly match color, not just brightness? So think about how would you do that. It was pretty simple with brightness because there's only 256 possibilities, but the full range of RGB colors, that's much bigger. With brightness itself, something you might think about is, well, how could I have each image be unique? Or that array, instead of having one image for each brightness value, what if each brightness value has a selection of images, and every time I find it, I pick randomly? Or I can't use the same image twice for certain brightness values. So there's a lot of ways I think you can improve the sort of uniqueness of this. And then, of course, this is kind of nice, but if I zoom into it, we're really dealing with these very low resolution images, so I'm not really getting much out of it. But I think this would be more interesting visually as a massive, large-scale print, right? So that you could step away and see it or go close and see the detail. So thinking about ways you might present that or represent that, whether it was a web browsing experience, could be interesting to think about. So I hope you enjoyed this Obama photo mosaic. And I hope you make some stuff with it, and I hope to see you again in a future video. Goodbye.